Sure nice of Mother Nature to cooperate there. Some storms rolling in from the north this afternoon, kind of a nice surprise there. And you can see a little bit of dust just below the center there. Anyway, that was some pretty cool animation, and we've got some charts. Let me get that switched over. And there's me. And we'll head to the maps. Let's do that. These storms rolled in from Oklahoma City. This started as a storm cluster last night in western Kansas there. And what you'll want to look at is up to the top of the chart there. Let's roll that forward, and you can see those storms coming in from about Gainesville to Sherman and down to Dallas, and there's that outflow boundary right there. And then by about 3 or 4, they're pushing all the way into East Texas. And then you'll notice just to the, let me slow this down just a tad, along the western periphery right here, around Mineral Wells, down to Palo Pinto, we get this storm blowing up right here. And that's looking pretty spectacular, definitely better than the storms further out to the east there. So let's take a look at the radar. And that's what things look like right now. So the updraft region is going to be pretty close to this little notch right there. And let's back that up a little bit and see where it came from. This was about 7:12 p.m. So the updraft area is right there, just slightly west of Comanche. So that's taken a south-southwest track there. Definitely a deviant mover. And there it goes, and we don't see the classic hook echo with that, but there is that little notch and that little appendage. And the tops on the storm were approaching 60,000 feet there, and it was quite spectacular there. I believe I have a yeah, check this out. This is the new GOES imagery 1-minute interval satellite photos, and this is starting out around 4 o'clock. Very spectacular. Looking at the top of that anvil there, you can see that V shape as the flow spreads around that updraft. And up to the north, a storm coming in from Childress and Paducah, so not quite over this evening. Anyway, we'll give that one more go and take a look at that there. And this is from the College of DuPage site, so you can go back there and get pretty much the same image. Some nice gravity waves there around the periphery of that anvil. Very neat to look at. All right, we'll do one more. We're not constrained by network air times or anything like that. So anyway, that's that storm developing along the western periphery of that outflow boundary as it moves southwest there. Okay, the synoptic environment. Let's start breaking that down. Go to the maps here and start with the big picture. Not much to look at in the U.S. We're losing a lot of the strong fronts, but we do have something out there in Nevada once again. We've had this persistent troughing out there along the west coast. So it appears we've got another fresh cold air mass coming in from the Pacific there, so making its way into the Great Basin area, and this is probably heading for Wyoming and Montana. All right, so what do we have going on out east? Okay, high pressure. Well, we can fall back and use that trick there, right there. High pressure off the southeast coast right there, bounded by that 1016 millibar isobar. Almost said isotherm there. And that covers pretty much this entire area right there. This is the zone of influence of that little piece of that Bermuda High there. So we go from 1016 to 1012, 1008, 1004. Okay, so this is pretty much just kind of a very broad pressure gradient. And then up to the north there, we see a Canadian system up there in Manitoba. Looks like some very strong polar air up to the north. And then down in Texas, what does all this mean? Well, based on what we've gone over, the prevailing flow should be running something like that right there. So very broad southerly flow. Looks like a little bit of troughing kind of embedded just south of that low pressure area right there. And then we've got what looks like a thermal low right there over the Texas Panhandle. This is not a very common position for a lee side low. We tend to find that around Clayton up to La Junta, Pueblo, up in that area right there. So this is almost certainly due to the very warm temperatures in that part of West Texas. And then here in Texas, well, pretty much southerly flow feeding right up into that thermal low. And a couple little boundaries, that zone of thunderstorms moving south embedded in that flow right there. But the large-scale picture, pretty much that, flow into that thermal low and then more going up to the north towards that Canadian system. So that's kind of the way we visualize things, starting with a big picture and then bringing in the complexity, and starting from like the big picture, the large scale synoptic, all the way down to the small scale, like the mesoscale, like we saw in the charts right here. All right, so now we can go ahead and do the mesoscale. So we'll do that. Let me get my maps centered here. And the green corresponds to dew point. So that's one thing that we look at this time of year. That gives us a measure of the moisture that the storms actually care about, not relative humidity, but dew point or mixing ratio. So when it's complex like this, it's better just to start from near the moisture or underneath the ridge down to the south, and we can see dew points in the low 70s along the Texas coast. And I'm saying we start south because things tend to be simpler in this area. It's less overturned by thunderstorm activity. So we just see very warm temperatures, southeasterly flow, in line with the synoptic pattern right there. And then just a gradual drop off from upper 60s dew points down to mid 50s around Big Spring, Texas. So a little bit of a dry line right in this area, and even some convergence to show for that right there. So I wonder how many people analyzed a dry line in there. It's not a very strong dry line, but I would certainly analyze it as one. 59 right there at I guess that's Sonora. 58 there at Sanderson. So I'm going to bring that like right through here and then up north. And then in this zone we don't have too much data to go by. So that would be a dry line right in there. And then as far as the position of the outflow boundaries, we would use satellite wherever we can, or radar indications. So to give you an example, well, this is a good example. So we'll run this up to the current time. And sometimes what I'll do is I'll actually put the county outlines on, which we can certainly do here on College DuPage on their website. Got some good flexibility there. And I might kind of go back a little bit, make sure I can see the boundary right there, kind of play around with it, and then I'll go in and draw that position, and then I'll transpose that to the hand-plotted chart. And on the hand-plotted charts, I definitely do county borders, because that helps me integrate all this data together. So I would take that, and I would put that on the hand analysis. And I haven't really had time to do that, but that's what I would do there. And then there's obviously another boundary up to the north, and I've got a different sector for that one. We can take a look up north. Okay. All right, I guess it's the other one. No. Well, I thought I had a sector set up for that, so we'll just look at this one here. And you can see the remnants of some other outflow boundary there around Knox City and Paducah. Let's run that back. Maybe we can see a little bit better. So bringing that all the way back to about 5:30 p.m. Looks like some sort of convergence line right there, and then once the outflow starts dumping down into that area, we get more of a convex appearance, and then it starts looking probably a little bit more like that. Another way to visualize this is with the NAM data, or the high resolution rapid refresh. And we look at the temperature product. Now this isn't very accurate, and I'm going to show you some examples of why this doesn't always work very well. Okay, so let me think here. Where did I put that animation? I think it's back in here. I've got like 50 windows open. Yeah, here it is. So I went to Pivotal Weather and pulled up the temperature product, and this is a 16Z run, because I wanted to kind of compare and see what things look like earlier. So there, this is around 1 p.m., and you can see the model derived cold pool there. So that's what's driving these boundaries here. So let's see what happened. Pretty much sending that straight down towards Lufkin. And then down to the south along the Gulf Coast, there's a sea breeze. So definitely quite a bit to look at. And then that goes up and meets the outflow boundary there. Now, when I said that this model is not always accurate, let me show you what it looked like earlier around 9 to 10 a.m. So I'm going to run this loop here and take a close look at where it's putting that cold pool near Dallas and where it's forecasting for later in the day. Okay, so this is 14Z. This is the 9 a.m. run. So starts out in Oklahoma City, and it's got it going more towards Texarkana and down towards Shreveport. So quite a difference there. These models are fantastic, but they don't always analyze perfectly where these systems are, and that's where the human element really comes in. You might be looking at data and you might be convinced it's going to go more towards Interstate 45 or East Texas, and then you would kind of adjust your forecast to reflect that. So obviously a much different picture there, and let's see what it looked like later in the day. We'll just bump this up to 21Z. So we're using the temperature product on this fine-grained model here, pool up there in northwest Texas. See how it starts out earlier in the day near Paducah and Crowell, and that takes a similar track towards the southeast there. And you can see up here it's projecting that to come into the Dallas-Fort Worth area sometime later tonight. So I'm not too sure if we're going to have any storms along that because the cap is pretty strong, and that's another aspect of this situation that we'll cover. In fact, let's go ahead and do that. I'm going to select an earlier model run so we can kind of look at the air mass. Now, I know that, we're kind of going over a lot of Texas products, will work the same as long as the weather patterns, the ingredients are similar to what we have in Texas today. So what I'm going to do is go ahead of this outflow boundary and go into maybe East Texas somewhere, and I'm going to pull up a skew-t. So this is what the environment looks like ahead of this convective system. Looks like some decent moisture right there, and a very distinct lack of capping. See the 700 millibar temperatures here, they're about 8 Celsius, which is on the low side of what we've been seeing over the past few days. So if we lift that, we get kind of a long, skinny parcel lift. And what I've done here, you know, I've been wanting to go into a little bit more detail, more of a beginner approach, but, you know, we've got so much going on tonight, and I'm going to just kind of try to do my best here. What I'm doing is I'm starting with the surface temperature here. These lines here, these are temperature. So a high temperature of 90 degrees, that's going to be about 32 Celsius. And this line right here, that's about close to mean sea level. So our temperature parcel lift starts about right there, and it goes up these dry adiabats. So basically like that right there. And then we start with our moisture, and what I try to do is I'll try to average out that green line right there. That way, instead of just taking the dew point temperatures at the surface, I'm taking more of a representative layer through the lowest 2,000 or 3,000 feet. And what I've done is I've kind of averaged it along these green lines. Those are mixing ratio lines. So putting that together, where those two lines collide, that's the LCL, lifted condensation level, and from there we've always got to go up the moist adiabats. Now they're not plotted on these Sharpie products, but we can use that little white line there. That's one of the parcel lifts. We can use that as a guideline. So I'm going to put that a little bit more to the left, maybe something like that there. So we do have instability, not a great amount, but it is enough for some thunderstorms. A little bit of deep layer shear there, showing on the photograph, slightly stretched out, and that's due to the difference in the light northwest winds aloft and the light southeasterly winds in the low levels. Now further out to the west, I'll show you the environment out there, more towards Brownwood. So what we're doing is we're kind of contrasting the environments. Looks like the moisture is a little bit shallower. The 700 millibar temperature comes up a little bit, so slightly more capped. So that could be that can make all the difference there. Let me try lifting that, doing it the same way, and you can see that we're starting to fall to the left of the temperature line, kind of in this, kind of in that zone right there. So that means we've got more capping going on, and then going further west out towards west of San Angelo, it looks like this. The moisture has definitely fallen off, low 50s to upper 40s dew points, and the 700 millibar temperature is still about the same, so we've got slightly increased capping and less moisture to work with, so that has a definite problematic effect on the storms. All right, let's get things moving along here. I want to go back to that surface chart and cover what's going on up north, since there's places other than Texas. Some fairly decent moisture there in Kansas. Temperatures or dew points in the mid to upper 60s. But it falls off as you get into Nebraska. So even though we have this little convergence line up there in Nebraska, not much moisture to work with. And a lot of the moisture that we do have is heading more towards Iowa, where they do have some thunderstorms. And let me bring that up. Okay, thunderstorms in Iowa. I wanted to try to cover some of the other areas around the country. Now, starting out, it looks like the cumulus field is a little bit high-based. It's got more of a large, coarse, granular look there. But sure enough, storms did end up blowing up anyway. So it looks like a lot of multi-cells there along that line just north of Des Moines. And then as we go out west, it looks like the storms are a little bit higher based out in that area. The anvils look a little bit more mushy in that region. And you've probably been catching glimpses of this thing. I wanted to kind of cover a little bit more of the ABI products on the new GOES satellite right there. Now, they offer this product here called low-level water vapor, which is a way of visualizing the moisture field with more sensitivity to the lower levels. Now, typically these products that we work with, the water vapor, on the past GOES satellites, those are more sensitive to the upper troposphere, say around 15 to 25,000 feet or so. And let me just show you a diagram of that. This kind of shows you the sensitivity. Typically your water vapor imagery products, they're kind of sensitive to that layer right there. That's about 400 millibars, which is about it's around 20,000 feet or so. But the low-level water vapor imagery is sensitive to lower levels. So this right here, that's about 10,000 feet. There's 5,000, so we're kind of picking up bits of the lowest part of the atmosphere there. And there was a feature that I was seeing earlier. If I back this up here, this is looking up there in northwest Texas. Childress is there, Vernon, Altus, and Abilene way down at the bottom, and Fort Worth way over here. Now we have to be careful not to look at the we don't want to consider the actual cloud material, which is like this stuff right here. This is anvil and cirrus, and what we want to look at is the actual clear air that's in this region here. And it kind of looked to me like there was an area of enhanced low-level moisture right there south of Childress, and it seemed like the storm was kind of propagating in that direction. Now you see how the anvil kind of overruns that gradually, but the moisture is still there in the lower levels. It seems like the storm kind of heads right for that right there. So we're going to try to cover a little bit more of this and see if these GOES products help us out. So this new technology, it's almost like I'm just kind of amazed that they come up with all these techniques and all this wizardry with the channels there. All right, let's go ahead and move on, and let's see what we're looking at next here. Oh yeah, hurricanes. Oh man, there's so much going on. Okay, we've got Alberto out there. NHC has got that. Where's my NHC graphic here? Yeah, there it is. Alberto, subtropical storm there, right? Showing 35 knots sustained, pressure of 1006 millibars. That's pretty high, and just a very, very slight eastward drift. However, the tropical models are bringing that northward into the Gulf, and that's something we've been looking for the past week or two. And it appears that is heading into the central Gulf there. Landfall somewhere between possibly New Orleans and around, I guess that'd be Gainesville? No, Apalachicola, somewhere in that area. So yeah, that'll be heading into the central Gulf there sometime later this weekend. Other than that, we shouldn't see much from that except a lot of rain. And then convective-wise, there's our convective outlook. Slight risk has been extended southward towards the Abilene and Throckmorton area. Severe watch for the Childress area, and they did have a mesoscale discussion earlier They were watching those boundaries there and looking for possible continued development of that system. So we'll check some of that out on the high-resolution rapid refresh panels. Okay, let's see what's up next. Let's look at the upper levels. There's a 250 millibar chart, and this is showing one of the master solutions to what's happening. And we've got this subtropical jet in the area that's helping to augment the storms. So we're getting some nice long anvils, especially down in the Houston area and along the southern part of the outflow boundary. Winds are up to about 70 to 80 knots up above 30,000 feet there. But you can see up there in Kansas, winds are a lot weaker. So it's going to be a lot harder for storms in that area to organize. And that's probably one reason why some of the storms in that area around Omaha are not that strong. It's that weakness in the upper level winds. We've got a polar front jet working its way onto the California coast. Seeing almost 100 knots there near Santa Barbara. Then down at 700 millibars, let's go down to that level, see what the cap is doing. And there we do see that the cap is a lot stronger as you go west. So where we've had those storms today, temperatures about 6 to 7 at 700 millibars, which is about 10,000 feet. And then you go out there towards Midland and Amarillo, we're looking at 12 Celsius. So in Fahrenheit, that's about 43 to 45 in East Texas versus 54 around Amarillo and Midland. So that's going to have a pretty significant effect on the soundings. And then a lot of cold air off the California coast there. So somewhere in here there's probably an upper level cold front. And probably an upper level warm front, maybe something like that there. Then down at 850 millibars, this is where we track the moisture. Looks like a lot of dew points in the 50s across the southern plains. So if we want to do this in Fahrenheit, we can definitely do that. Looks like maybe a little bubble of 60 kind of in this area right there. 55 would be in this quarter right there. And then 50, that just falls on the 10 Celsius line. Somewhat like that there. Looks like a kind of a weak low-level jet, and it is bringing some moisture up, but you can see the velocities are kind of on the weak side, about 20 to 30 knots out there in West Texas. And that's bringing most of the moisture out towards Missouri and eastern Iowa. Wow. Usually we don't get to this isobaran thickness until... No, I mean, usually we hit this chart pretty early, like about 4 or 5 minutes after, and it's already 29 after. So there's been a whole lot to cover tonight. So the strong cold front, that's well up to the north here in Canada. This is the position of the strong polar front. So it's being driven by that 1021 millibar high in the Hudson Bay area. So the Hudson Bay polar air factory is still definitely active. But you can see that this Bermuda high, that's becoming the dominant player, and that's bringing a whole lot of warm, moist air up from the Caribbean and Atlantic. And then out to the west, we can see a little bit of that cold air coming in. Remember, there's a lot of cold air right there on the west coast. So just looking at this, I'd be inclined to think that the frontal systems are probably something like that right there. So still stuck back there in Nevada and California. And I think this would probably be a good time for me to take a look at chat. So let me go ahead and do that, and let me get you some satellite imagery. All right, let's see what satellite imagery would be good. I guess, yeah, let's do that global one. Let me bring that up here. We don't see this very much, but it's kind of neat looking at the planet from 22,000 miles there. All right, so let me take a look at chat here, see what's going on there. Okay, Michelle Curlin, right on time, sunny and warm in Ventura. David Lumbert, Maumelle, Arkansas, 79 degrees, dew point 68. Erica Baker, Coffeyville, Kansas, 82 degrees over 64. Justin Pulliam, watching that storm moving down from North Texas. Willie Greenway in Georgia with us, and Justin Pulliam commenting on the 60,000-foot tops. We've got Funwood Tech with us, and Jeff Krob, 83 degrees in Maryland. We have Sue M here, and Burl H, 82 in Iowa City. We have Chris Tyne and Rat in Tucson. Funwood Tech. Google bus on a Texas highway. Was that on the opening clip? I didn't see that. I remember seeing a bus. I didn't think it was a Google bus or anything like that. Okay, Shirley Keast, 70 degrees in Michigan. Appreciate the comments. Chris Tyne, Willie Greenway thinks fluid about 2,000 feet up. Yeah, today's image that you saw there of the storms, that was taken from 250 feet. So we didn't go up too high today. We were definitely a lot higher a few days ago. Good evening to Carl Berghoff and Patrick Motes. I appreciate that. Christian Flock checking in from Yukon. Got some great shots. Yeah, there were some photos that I wanted to share with you all, but I had some viewer photos that were emailed in, and I haven't been able to get to that because of all the weather all over the place. Carl Berghoff, seeing some storms there. Justin Pulliam liking the power in that storm. Justin Pulliam asking about a new version of Digital Atmosphere. No, actually, that's just a customized script. I had to do some shading in there. I did have to do a little bit of tweaking to get the... There was a line limit of like 200 characters, and I got rid of that. So I'm going to be releasing that pretty soon, but it does allow you to do that shading now. At least you can do more than like 3 or 4 levels. So in short, yeah, that capability has always been in Digital Atmosphere, but I've just only now kind of expanded that. Jeff Krob, still hybrid, subtropical phase. If it can get away from the dry air, it may go full tropical. Talking about Alberto down there near Belize. Okay, I'm going to have to just kind of very quickly go through all the rest. Hello to Cthulhu there. Justin Pulliam asking about Comanche. Yeah, we went over the radar just a little bit earlier, and I've got that right here. There's the latest frame on the storm. It's actually picking up a little bit here. So this is located just northwest of San Saba. And it's got a little bit of a weak echo region. Very small one. But let me see if I can get that to plot here. Yep, there's that overhang on that storm from northwest to southeast. Let me bring that more north to south. And this is a lot different from what we had with the storms over East Texas. There was practically no overhang in that region. So conditions out west are definitely more favorable, even though there's more capping. So it's probably proximity to that very strong upper level jet. In fact, let me show that to you. It's better to show these things. If we go back to that 250 millibar chart, yeah, you see what happens when you go from East Texas, where the winds are only about 20 to 30, out to this area where they're more like 60. So that's a big change. That's probably one of the big factors there why things are better for these storms out west. Pretty good overhang, lots of 70 dBZs up at 25,000 feet. Let's look at the circulation. We'll zoom in nice and close on that. And let's see. Start with the base velocity. It's good to do that so you can spot problems right away. Got to keep in mind where the radar is. It's off to the northeast. And really, I should be looking at this on the San Angelo radar, but we'll just kind of work with what we have. We see lots of outbounds and some very strong inbounds right there off to the southern part of the storm. So this is telling me that there's probably a circulation kind of like that. Let me just kind of throw a dot kind of in the center of all that. Okay, so this segment that's heading that way. Okay, so yeah, that we're probably overshooting a lot of the more important circulations at that range. But I don't know, this probably samples it okay. There's the center of the circulation right there, just kind of a broad, very strong rotation. And we're seeing, well, this is up at about 12,000 feet, but this is about 34 out and about 36 in. So that's about 70 knots of rotation. And even though that this is up at about 12,000 feet, this should be perfect for capturing the mesocyclone, because typically that's a mid-level feature. That's going to be up at about 10 to 15,000. And your more tornadic circulations, those are going to be quite a bit lower. All right, spectrum width, anything to look at there? Not really. And then there's echo tops showing about 54,000. So that's quite a storm. And wow, look at that reflectivity. We're seeing 73 to 74 dBZs. So there's probably some very large hail on that, and got a tornado warning. Severe thunderstorm capable of producing a tornado near Skeeterville. Wonder how they got that name. Moving south at 25, tornado and golf ball sized hail. Radar indicated rotation, so we don't have a spotter reported tornado, but I guess they're watching for the potential for something to touch down. And just let me finish up the chat real quick. Trent Tubazuski, welcome to the webcast. Jeff Krob mentioning some of the features there in wind grids, or yeah, I think wind grids. Ryan Toomey's, welcome to the webcast. And very good. Okay, so you know what's next? This is where I get my charts all sorted out. All right, let's go into that forecast. All right, well, we do know that these storms are moving towards the southeast. They're kind of heading towards the better moisture, and the stuff out west is a little bit more organized. So let's see what the trend is overnight. Looks like our cell out west, not the one down near Brownwood, but the one up near Childress. Looks like the high-resolution rapid refresh has that persisting until about 6 in the morning. So there's probably some support there from the upper levels. And we're bringing that down. Yeah, this is actually appears to be coming from even further north, out around Dalhart and Amarillo. So let me just take a quick look and make sure that we do have convection up in that region. In fact, I'll just switch over the radar, take it up to Amarillo and see what's going on. So to verify that model, what I'm looking for is maybe some elevated type showers, and it appears I'm not really seeing that. So looks like our model is not quite verifying. So we're looking up in the eastern Texas Panhandle, And yeah, not quite anything there. So yeah, you would have to take that and adjust your model output just a bit. But any convection that does get going and persists, that'll probably keep going for at least several hours. And quite a cold pool along with that little cluster that the model had forecast. And let's look at that on the oh, we got the 0Z data in. Let's check that out. The 0Z update, this might give us a little bit more accurate projection. So there's our Childress storm. I'm starting with the temperature field first. I just kind of want to see what it does as far as cold pools. Yeah, it looks like it may not be... It's not handling that Brownwood stuff very well. It appears that that's going... Yeah, the actual location is kind of in that area right there, and the model's trying to bring that more towards Austin. So it's not handling that deviant motion very well on that particular storm. So let's go into the convective forecast overnight with the new 0Z data. And yeah, this looks more reasonable. You can see very little in the eastern Texas panhandle. Okay, I'm sounding like a broken record, but out there near Mangum and Elk City, the model is picking up on that convection, which is definitely there. So this looks more reasonable. So let's bring that forward. Okay, a quiet night. So the model is flip-flopped, and you can see that if we didn't have the benefit of the 0Z data, just going to the radar and verifying what you have there can save your bacon there. So obviously nothing, looks like nothing tonight. So the stuff we have around Brownwood and up there in Mangum, that should die on off. So looks like it's just a little bit too far away from that subtropical jet to the southwest. However, there will be boundaries being laid down overnight, so we got to keep that in mind. So this whole area here may have boundaries if anything gets going tomorrow. All right, so let's head more into the medium term. We'll start out with tomorrow's upper level chart. There's what things look like around daybreak. It looks like a pretty strong upper level low coming into the western U.S., but here in Texas we're going to be under a ridge. So that may shut things down out west. Looks like some good chances again in Arkansas and Louisiana. I just don't know how far west it's going to be. Gradually by Sunday, it looks like the polar front jet starts making its way into the Four Corners and Wyoming and the Dakotas. So initially the exit of that jet will be in the Dakotas. And it looks like as we go later towards Monday, it starts exiting more towards Nebraska. So that should bring some of the activity further south. Meanwhile, Alberta makes its way into the central Gulf Coast. And then out west, it looks like some of that troughing finally arrives in Colorado in the Four Corners area and the High Plains. Looks like one good shortwave there around Kansas. However, we're now under southwesterly flow, so we're not going to be seeing this northwesterly flow stuff that we have tonight. So all the storms are going to be moving mostly to the northeast or the east. So this one strong wave heads up into the Dakotas on Tuesday. However, more troughing out around California. So this may bring a couple short waves into the Central Plains and the Panhandles. So maybe some storm prospects gradually going up during the week. Some ridging on the high plains around Friday. And then some very strong height falls out in California. And then that starts making its way into the Central Rockies. And then that emerges out into the central U.S. around next weekend. Not this weekend, but the next one. One important development, though, is, let me run this back. It looks like this subtropical high is going to be building in very strongly look at the 591 decameter contour here and watch how it grows. There's 591 on, let me run this back a little bit. Let's see. Yeah, there's where I saw it. Okay, so 591, this is going to be around Wednesday the 30th. And then we can see that creeping up into Texas around the 1st of June. And then up into Oklahoma around the 2nd. So this is parking itself over Texas, and what this means is a high over Texas and very weak flow aloft. So there will be easterly winds in Mexico aloft and westerly winds in the Central Plains, but here in Texas we are going to be kind of high and dry. So the next couple of weeks looks kind of active from the Panhandles up into the Central Plains and the Dakotas, but I don't see much really south of I-40 except for maybe some spotty activity. And let me just take a quick look at the NAM, and then I'll just kind of blow through the GFS real quick. NAM is showing the approach of that system out in the Gulf. You can see that heading up there towards New Orleans, and the NAM has been kind of the most westerly of a lot of the models. So I would take that New Orleans thing with a grain of salt. It may be heading more towards Biloxi or Pensacola. And let me see how things look in the plains. Looks pretty quiet. Looks like we're going to be ridged out. And then by Sunday and Monday, high plains action. Anywhere from Interstate 70 northward into the Rapid City area. So that's where you're going to want to be if you're going to be chasing this weekend. Although I guess some people are probably heading to the Gulf Coast. I wouldn't be surprised. And then we'll pick that up with the GFS. You can see the GFS has taken that more towards Mobile. Remember, the NAM was going more like this. And then for next week, yeah, it looks pretty quiet down south, but there's one strong storm there at Dodge City for Monday evening. Looks like redevelopment there along the boundaries, again, there in western Kansas. Then looks like some quiet weather as that ridge builds in from the southwest. However, there's that troughing showing up out to the west. And then we see prospects pick up in the Dakotas. Looks like a very potent weather system up there. That's going to be for the Saturday the 2nd in the Dakotas. Then that moves up into Manitoba there. Other than that, looks pretty quiet, and looks like some of the northerly flow pushes south on the 4th. And then we start getting some upslope flow developing on the west side of that around the 5th. So once again, high plains action. I do see what looks like maybe a little bit of northwesterly flow. You can see in the thickness contours, there's flow like that around the 5th and 6th. So that tells me that maybe some of these storms in southwest Kansas may make it to the Red River around the 5th and 6th. And then looks like a couple more fronts push south, maybe breaking up the ridging a bit. So we're not totally over with spring. That's one good thing. And that's the last frame I have there for June 10th, and June 10th to 15th, that's when we start the transition over to summer. All right, so that's about all I have. I appreciate you all watching. Let me take one quick look at chat. Okay, a little discussion there about the storm, the tornado warning. Yeah, let's take one last look at that, and let me bring up GR level 2. Let me go to the San Angelo radar. Looks to me like they should have put the San Angelo radar kind of in here. I don't know, I guess they had their reasons for that. Anyway, storm heading into northwest of San Saba. Looks like a definite hailer for sure. So what I'm going to do real quick is I'm going to put a dot in the updraft areas. This is probably where you'd want to be if you were a chaser, somewhere in this area. But you can see that when we go up to the higher tilts, look at that higher reflectivity aloft up at about 39,000 feet. In fact, here's 31,000. So that would probably, we'd probably see that as a lot of darkness overhead, lots of lightning, especially cloud-to-cloud lightning, maybe a few long CGs coming down, maybe a few hailstones. And then there's the very top of the storm. This is up at about 50,000 feet. And then we compare that with the low level. So the top of the storm shifted over the updraft region. That's definitely a indicator of a very strong storm. And what's this down here? This looks like some sort of left mover or something. No, I was just going by the curvature there. I don't think that's a left mover. That's just some stray cell that's out ahead of the line. Let me look at the dimensions of that. Yeah, that's topping out at about 35,000. Just, again, this is probably not a, that's not a left mover. I was kind of led astray there. In fact, not much of any rotation on that storm down to the south. And then looking at the velocity before we leave. Looks like some weak rotation in there. Keep in mind the radar's out to the west. There's the inbounds. There's the outbounds. And I'm seeing about 55 in, 9 out. Let me fix this for you real quick. What I'm trying to do is I'm trying to draw out the rotation a little bit. Yeah, there we go. I set it at 90 at 7. You know, I should just do the actual storm motion. Let me bring it from the northeast. That's probably about as good as I can do there. 14 versus 47. Yeah, that's a little bit better there. Okay, so anyway, center of the rotation right in this area there. It's still pretty broad, and it's right in that notch area. So anyway, I'm sure that's making a few chasers happy. It's been slim pickings down here in Texas this summer and pretty much all over the southern plains. So it's good to have something to look at. Okay, that's all I got for tonight. I appreciate y'all watching. Y'all take care, and tomorrow is Saturday. Normally that's when we're off, so I'll just have to look at my schedule and see what we're going to do. I know we took yesterday off, so we'll look at the weather and see what's going on. Anyway, thank you all for watching. Take care, and we'll see you either tomorrow or on Sunday. Have a good one.